Hello everyone. Today we will talk about C++ operators and operator precedence. Today's agenda is about arithmetic operators, arithmetic assignment operators, precedence of arithmetic operators, increment and decrement operators, logical operators, and then operator precedence overall, including all arithmetic and logical operators. You can see different values on the screen, that is 5.13, 7.5, 10, 2. These are just random values. And variables, these are x, y, and z. So for a simple C++ program, you can use these values just like you have to print these values on the screen, or you can print these variables values on the screen. But life is not a simple one. It goes to the complexity, and you have to write the programs that map to the complex problem. So from the simplicity, you have to go to the complexity. You have to come out for the desired results. You take the input from the user, you process those inputs, you put those inputs in some mathematical expression, or you have some formula, or you have to find something in order to get the desired results. For example, if you want to find the rectangle perimeter or rectangle area, you might have some parameters. You have to take input from the user, and then those values, just like the values we have over here, these are just simple values. You have to put these values within a mathematical expression or a formula according to the problem. You will be having a specific formula for that, and then evaluate it and give the result back to the user, show the result back to the user. When you simply see these values, you cannot conclude anything happening in between these values. But when you write operators in between these values and these variables, these actually becomes arithmetic expressions. So arithmetic operators are symbols that perform operations on variables and values. Arithmetic is performed with operators. So you have to apply these operators to perform the operations on two things, variables and the value. And arithmetics cannot be performed without operators. So arithmetic operators are listed in the following table. What kind of arithmetic operators we have? Addition, subtraction, multiplication, division, and modulus. And we have already seen these type of arithmetic operators within our algebraic expressions. Like you can see that we have f plus 7. So the corresponding C++ expression you can write as it is, f plus 7. In the second case, you have the subtraction, p minus c. You can write the same. But for multiplication, you can see that it's written over here bm. But when you write bm in C++ program, it will consider as bm is something new variable, and it will give you an error that you have not declared bm, although you might have declared b and m separately, and you may have given some values to b and m. But when you write here for multiplication as bm in C++, it will be considered as an error, and the compiler will consider it's that you have not declared this new variable bm. So you have to be careful at this stage that for multiplication you have to write static sign. Then for the case of division, you have to write the same as you write in the algebraic expression, and for mod you have to write this percentage sign. So for using the modulus, but you will get, it's actually gives you the remainder of the integer division. And for this slash sign used in the division, it gives you the quotient. Result of arithmetic operators. Arithmetic operators can be used with any numeric type. So these operators like addition, multiplication, these can be applied to the operands which are having the data type, any data type, numeric data type. So an operand is a number or variable used by the operator. For example, we have the integer 1 plus integer 2. This is our algebraic expression. In this case, plus is an operator, and these on the variables on which it is operating. These are called operands. The result of an operator depends on the type of the operand. So if you are using these operators, so what type of result you will get? So if the both operands are of integer type, obviously you will get the result which is of integer type. But if one of the operand is of double and the other is of integer, it means that you have the mixed data type expression, then the result would be double. Now you can see that 12 slash 3, which is the division, you get the quotient, and 12 modulus 3, you get remainder. So it is the case for the other example as well. Arithmetic expressions. Arithmetic operations can be used to express the mathematical expression in C++. You can see that we have different mathematical expressions over here. We can represent these mathematical expression in the form of C++ arithmetic expressions. So you can see that we have b square minus 4ac. How you can write the corresponding C++ statement? It is for b square, you have to write b static b minus 4 static a static c. You cannot write directly 4ac in the C++ in C++ program. It would consider as invalid variable. So x, another expression we have x parenthesis y plus z. So in this case too, you have to write static sign in between this x and y and before the parenthesis. After that, we have 1 over x squared plus x plus 3. For this case, you have to write 1 over x squared, you have to write x static x plus 3, and you have to include this expression within the parenthesis. Now come towards another expression, which is a plus b divided by c minus d. Now you have to write over here a plus b. You have to write this expression within parenthesis divided by this expression within a parenthesis. So what will happen if you do not write these parentheses? If you do not write these parentheses, what will happen that as in C++, there is an order of precedence for the operator. So first of all, 1 over x will be evaluated, and the result of that would get multiplied with x. Then the result will again added with x, and then final result will be added to these 3. So we have to write this parenthesis to show that we have to evaluate this expression first, and then we have to take the reciprocal of that. In this case too, if you don't write the parentheses, the result would be different. So you have to be careful while writing these arithmetic expression in C++ program. One versus many operations in arithmetic expression. You can see on the screen that we have arithmetic expression or a mathematical expression as well. If you write it in C++ program, there is no confusion. This is one of the most simplest arithmetic expression containing one operator and 2 operands. And there will be no confusion of executing such a statement. But in the case of this expression, you can see that we have multiple operators. The compiler has a choice to evaluate each operator one by one or the sequentially. So in this case, it have to make a decision. Okay, what operator it has to evaluate first? Either it should plus, minus, multiply, or divide. So in this case, the situation is complex and there is a confusion that which to execute or apply for. So for that problem, we have a solution that in C++ program, we have the operator precedence. An operator precedence is the order that an operator is executed. So there is a list or the order containing the operators with high precedence, and then you have the low precedence and going the level decreases. So it have to take care of this list. So it actually executes the operator which has high precedence. Some arithmetic operators act before others. For example, multiplication before addition. So according to the operator precedence, multiplication have high precedence as compared to the addition. So in this case, what will happen? It will follow its own rule. It will follow the order in which the operator have to be executed. But what if you have the case, if you want to evaluate this first, if you want to add x plus y first instead of doing this multiplication? So you have to write, you have to include this thing, that is x plus y, within the parentheses, because parentheses have even high precedence as compared to multiplication and division. So whatever inside the parentheses, it will be solved first, and then other can be solved according to its list, according to the operator precedence. So we have to write the parentheses. So example is that we find the average of the three variables, that is A, B, and C. So for average, what is an average? It is the sum of all the items divided by the total number of items. So if you write A plus B plus C divided by 3, you will get an incorrect result. But instead, you have to write, you have to put this addition within the parentheses and then divide by 3 to get the correct result. Rules of operator precedence. So here is the rule. Here is the order in which the compiler will execute these operators. First of all, the highest precedence is of parentheses. Parentheses will be evaluated first. And if the parentheses are nested, what will happen? The expression in the innermost pair is evaluated first. If there are several pairs of parentheses on the same level that is not nested, they are evaluated left to right. So if there are multiple parentheses within a single statement, so what will happen? It will evaluate it from left to right. And then the second level of precedence, which is a lower precedence as compared to this parenthesis. So in this case, in this level, what operators come here? Multiplication, division, and modulus. So it evaluated second. If there are several, they are evaluated from left to right. So so if multiple operators come within a single mathematical expression or arithmetic expression, then in this case, it will evaluate from left to right. Now come towards another level, which is even lower than this one. So addition and subtraction, and it evaluates last. If there are several, they are evaluated from left to right. Operator precedence example. Here is an example. You can see that we have 20 minus 4 divided by 5 multiplied by 2 plus 3 multiplied by 5 modulus 4. So according to the operator precedence, we know that multiplication and division and this mod sign have high precedence as compared to this addition and subtraction. But in this case, all the same level operators come in this expression, and both multiplication and division are here. So what will happen? How these will be evaluated in this case? If we have multiple operators of the same level, these will be evaluated from left to right. You have to go from left to right. So while going from left to right, we encountered that there is a division sign that is going to be in between 4 and 5. So 4 by 5, this will be evaluated. Then come towards that move forward. Here you can see you have the multiplication sign. It will be evaluated first. Then and again, this is plus. We will ignore at this level as we have the multiplication sign, which has high precedence as compared to this. So we are going to evaluate this first. 3 multiplied by 5. This will be evaluated. And then after that, we have this mod. This will be evaluated. So all the operators that comes in the same level have been evaluated at this time. Now come towards the lower precedence level operator, that is the addition and subtraction. Both are there in our expression. So we have to evaluate again from left to right. You can see that we have to evaluate now 20 minus whatever we get at this end. The result would be subtracted from 20. In the next statement, you have this addition sign. So whatever you get at this end and whatever you get at the other end, both would be added together, and the arithmetic expression would be solved finally. Assignment expression abbreviation. Program can be written and compiled a bit faster by the use of abbreviated assignment operator. C++ provides several assignment operators for abbreviating assignment expressions. Addition assignment operator. You can see that C equal to C plus 3. This is abbreviated to C plus equal 3. So you can simply write this type of mathematical expression or arithmetic expression in the form of C plus equal 3, which is a compact form, and it's a little bit faster than this. Statement of the form, variable equal to, so this is variable equal to variable, this is the variable operator, this is plus is the operator, and the expression. You can have an expression, we can gain. Here you can have a value as well. This can be written as variable plus, which is the operator over here, equal expression. Other assignment operator, or you can say we have the example like d minus equal 4, which is equivalent to d equal to d minus 4. E multiply equal 5, which is equal to e equal to e multiplied by 5. And similarly, it's the case for the rest of the operators. Arithmetic assignment operator. So in this table, we have summarized the operators over here, but here we have assigned some values to these variables used. That is, we have assigned 3 to C, 5 to D, 4 to E, 6 to F, and 12 to G. And then we actually evaluated these expressions to get the result at the end. Increment and decrement operators. Increment and decrement operators are unary operators as they require only one operand. The arithmetic operators that we just studied are binary operators. They require two operands to operate on. But here in this case of increment and decrement operators, we require only one operand. That's why it's called unary operator. So plus unary increment operator, its name indicates that it's going to increment a value. So it actually adds 1 to the value of a variable x plus, what does it mean? That it's going to add a value 1 to the previous value of x to change the current value of x. So x equal to x plus 1. So you have two versions for plus unary increment operator. In this case, you have pre-increment. Its name indicates that first of all, it have to increment, pre-increment. When the operator is used before the variable, so pre means it's used before the variable. Here the variable is c, and the operator is plus. It's used before the variable. What does it mean? That variable is changed. How it's changed? Its value is incremented by 1. Its value is now modified first. Then expression it is in is evaluated. So first the value is changed. First is the value is incremented. Then the incremented value would be used in the expression. Now, in the case of post increment, when the operator is used after the variable, you can see that here plus sign is written after the variable. So what does it mean? The expression the variable is in execute. So it execute first, the expression execute first in which you have that variable, and then the variable value is changed. So then after that, after evaluation of the expression, the value of that variable incremented by 1. In case of minus unary decrement operator, you can see that you have to subtract 1 from the value of a variable. Like x minus, what will happen in this case? Decrementation would happen. Decrement by 1, x equal to x minus 1. So it's going to subtract 1 from the previous value to modify its current value. pre-decrement. Its name indicates that it have to decrement first. The decrementation sign or the operator is before the variable. So what does it mean? It's going to change the variable first and then the expression it is in is evaluated. Similarly is the case for post decrement. The operator is after the variable. The expression the variable is in execute first and then the variable is changed or modified. Example, if c equal to 5, then when you write c out plus plus c, which shows that you are now going to print plus plus c. So it's complete expression. This expression, what is going to do, this is the C++ statement, which is going to print the value of plus plus C. So what will happen as it is pre-increment, the value of the C would increment first and then it would print its value. So C is changed to 6 and then print out. Now, in the other case, if you have the cout statement, which is used to printing out some variable value on the screen, in this case, C++ is written over here. So what will happen? First of all, the previous value, the current value of C would be printed on the screen. And after printing this value, the value of C would be incremented by 1. So it print out 5, the current value on the screen, and then C becomes 6. When variable or not in the expression. So here we have considered the situation in which we were using increment and decrement operators within an expression. But what will happen if these variables are not in the expression, or we have simply plus plus c statement over here, and then you can see that now in the second statement we are printing out its value. So these are now two statements. Instead of one statement, we have split it into two statements. And then for the other case too, this is the pre-increment case and this is the post-increment case. So in this case too, we are going to print the value. But for both the cases, as these increment and decrement operators are used alone, the value would be same. Summarizing the increment and decrement operations in a table. So if you have plus plus pre-increment in plus plus a, let's suppose, then increment a by 1, then use the new value of a in the expression in which a resides. Then come towards plus plus post-increment, use the current value of a in the expression in which a resides, then increment a by 1. Pre-decrement b by 1, then use the new value of b in the expression in which b resides. Then we have b minus minus, which is the post-decrement. Use the current value of b in the expression in which b resides, then decrement b by 1. So it is an example. You can see that we have the same structure of C++ program. You have to write hash include ISV. Then you have to write the main function within a main function. How it starts with the curly brackets, and within these curly brackets, you have to write your main C++ statement. First of all, you have to declare a variable which is C, and then you can initialize it some value. So in declaring it and then initializing with 5 value. So if you are going to output this value of C, what will happen? Correctly, C have 5 value. So obviously 5 will print on the screen. Then in the next statement, what is happening? It's the post-decrement operator. In post-decrement operator, and the second thing we have to check that it's used in an expression in the C++ statement, in the expression in which it's going to print its value, it's going to do something on this value of C. So the expression would evaluate first. That is the value 5 will be printed on the screen, and after printing the value of C would be incremented as this is post-increment operator. And then when we display its value, as the value has been incremented by 1 and it becomes 6, the incremented value would be displayed on the screen, that is 6. Now come towards the pre-decrement of operator. As we have to change the effect, we will again initialize or we reset the value of C by 5. Now currently 5 is the value in C. When we display it, it will print 5. Now if you write plus C, so first of all, what will happen, as this is pre-increment, then the value would be changed first, and then the expression is in it would be evaluated after the incrementation. So increment by 1, it becomes 6. So now C contains value 6. So if you display the value, it would print 6 on the screen. And again, if you print C, same, if you are referring to that memory location of C having the value of 6, then you, even if you print it 100 times, if you write C out C, C out C 100 times, all the time you will get the same answer, that is 6. Nothing is going to change right now. Okay, return 0, and by the curly bracket close, the main function will be closed. Now you can see that the result of the first case, we have 556, and for the second case, we have 566. This is the output. So come towards the logical operators. So besides arithmetic operators, we have logical operators. C++ defines these logical operators, that is less than, greater than, less than or equal, greater than or equal, and equality sign, which is the equivalence operator. You can compare any variable. So these operators are used to compare two variables. Characters, if so it's very easy in case of the variables having the numeric type value. You can check whether this value is, when you compare the variables, and actually what variables can have some values in them. So when you compare the variables, actually you are comparing the values that these variables hold. So it's very easy in case of numeric type. What about the character? So if you use, if you are going to compare the variables and that have the character data type, what will happen? Actually, each of the characters have its corresponding ASCII code. So when you compare the character, their ASCII code will be compared, and you get the result according to their ASCII code value. All answer will be true, not 0. So if you get the true, it may have any non-zero result, and you get false result if you get 0. You can extend the logic with and, not, not. So not simply these operators have been used. These actually the operators use the relationship between these numbers or the values, whether this value is greater than or equal. What does it show? It shows the relationship between the numbers. And when you check that, is it greater than or equal to other number? The answer is either yes or no, true or false, 0 or 1. So you can extend this logic by combining different types of these logical questions. You are actually questioning whether this is, you are finding the relationship between the values, whether this relationship is true or not. So you can combine these types of relationship. You can extend your this expression by having a multiple logical operations within your expression. But how you can combine these chunks of your logical operators expressions? You can combine these expression by having these logics and or. So if you get the result, let's suppose one of the chunk of the logical expression, you get 1 over here, and the other chunk you get 0 over here, and in between that you have written over here and. So what will be the end result? We are concerned here about the end result. If we are extended it, then we have to end up this expression with our final result. In this case, what is happening if we have written and in between these two chunks, or in these two logical expressions, then the case is the same as you have learned about logic gates and logic gates, in which we have the case that if we have 1, 1, 1 and 1, If both have one value, the result will be 1. And if one of them, if one of the operand is 0, the result will be 0. So the case is the same here, and the case is the same for OR as well. So if one of the operand is 1, we can get the result as 1. Now, for in case of not operator, you can use it even you can use it with your final expression. Whatever you get the result at the end, you can toggle it. You can reverse its result. Let's suppose the final result of the overall expression you get at the end as 0, but with the use of this not operator, the 0 becomes 1. More operators. We have the equality, which we can write over here. We can compare two variables value by writing x double equal sign. You cannot write a single equality, which is considered as an assignment operator. If you write here single equal, this wouldn't be the same as you see in your mathematics, like x equal to y. No. If you want to check the equality, you have to write this double equal sign. If you write a single equal, it's not going to check any relationship, but it's going to assign the value contained within a variable y to the variable x. Not equal, it's the same. If you are checking between two variables value, one value is not equal to the other. And greater than or equal, so both the relationship, whether it's greater than or equal. So if it is equal, the condition is true. If it's greater, the condition is true. Similarly, it's the case for less than equal, and come towards the more operators, simply greater than, less than, and thing to remember that no space within the equal sign. And then bitwise AND. So we are just applying this AND operator within two separate expressions and getting the result at the end. What about if we want to apply and if we want to do bitwise AND? So if you have a certain value and you represent it in the binary form, having the bits containing the values zeros and 1, and then you can apply bitwise AND. It means that every bit would be ANDed together. So if all ones and you are applying bitwise AND, the result will be 1. If any of the bit is 0 and you are applying bitwise AND, then what will happen? If the end result would be 0. So this is the case for the OR as well. But here you know the logic of OR. You have to keep the logic of AND and OR in mind. Next, you have bitwise NOT. You can also toggle the each and every bit of a value by using the bitwise NOT. At the end, we have the precedence of the operators that we covered so far. You can see that we have the parentheses, we have this plus plus and minus minus postfix unary operator, and you have the static underscore cos. All these come within the same level, and if these encoded within a single expression, then you have to decide and you have to go from left to right and solve each and every operators that you encounter in your way. And then come towards plus plus minus minus plus minus, the prefix unary operators, and then you have the multiply, divide, mod. Then the level which is lower than this one is plus minus. Then you have this stream, inversion, and extraction operators. After that, we have the relational operators, which is less than or equal, greater than or equal. Then come towards the equality operators. And after that, we have these conditional operators, which is question mark and full colon. And then you have equal, plus equal, minus equal, multiply equal, divide, and so this is operator assignment. You have the assignment, and it would be from right to left. Then come towards comma, which is you have to apply it from left to right.